At a hard completing the square problem. So what are we going to do with this? We're going to solve this by completing the square. What's kind of our first step in completing the square? Okay, we've got to get the x squareds and the x's. Our goal is we want to get it into what form to complete the square? Okay, good. X squared plus bx equals some number, right? You want to get the x squared plus bx by itself, okay? So what does that amount to then?
Minus 10.
You're going to subtract 10. While we're at it, what else could I do?
Add a minus.
Subtract 15x. So let's push the x's left and the constants right. So subtract 10, subtract 15x, and that's going to give us 3x squared minus 21x equals, what, negative 38? Okay, now what? Okay, and in fact, we don't even really have to pull a 3 out of it. What could we do instead? We could undistribute a 3. We could just divide everything by 3, both sides by 3. Right?
Yes,
so if
sir.
we do that, if we divide each side by 3, then that's gonna, we'll just divide term by term. So 3x squared divided by 3 is x squared. Negative 21x over 3, just negative 7x. And on this side, we're stuck with a fraction. All right, so now we got everything in the right form. Now here's the part where I want to make sure that you can make this really easy, right? If you just do this using my little trick, I think that's helpful, right? So we're going to combine 2 steps in one. Our goal is on the left side, we want to get something that is a perfect square, right? So we want to end up on the left side with x plus or minus just some number squared, right? And then to do that, we're going to have to add a number here, right? We have to pick just the right number to make this a perfect square trinomial, so it factors into something 1 factor squared. And I'm going to have to add that to both sides. So you remember this? So we're going to add to both sides the same number. Okay? And then our goal is we just ultimately need to know when I write this as a perfect square, so this is really then becomes one of the, similar to the very first problems that we solved when we were in this section, right, where we were able to just isolate x. We've got x plus or minus some number squared just equals some number. And then I can easily isolate x by just square rooting both sides and adding or subtracting some number, right? So that's our template. It's going to work that way every time. What do we do first? Good, so we want to know, first let's figure out what goes here, right? It's going to be half of b. So what goes there?
7 halves.
Minus 7 halves, okay? So we already know when we square root both sides, we're going to get x minus 7 halves on the left side. Okay, but to get that, what did we have to add to both sides?
That half
Okay, so negative 7 halves squared, which is what?
49.
49 fourths. Right? And so, you know, we don't really need it up here. We already knew what we were going to get on this side, but we needed to know what we had to add to negative 38 thirds on the other side, right, to see what number we ended up getting, okay? So we got to add those fractions up. Let's do that. So 49 fourths minus 38 thirds. How am I going to get a common denominator? So I'm going to multiply top and bottom here by 3. Good. How about over here? And what am I going to get? So 3 times 49 is 147 minus 48 times 3 is going to be, what, 162? Or 152. Oops, that's at 12, not 3.
Oh.
Okay, so what do we end up with? Negative 5/12. There we go. Okay, now that we're there, it's pretty easy. So last couple steps, what are we going to do? Square root. So over here, we just get x minus 7/2 equals, how about this side?
Square root of 5 over square root of
Okay,
12.
I, you need an I. What else? I'm square rooting both sides. Gotta get a plus or minus in there. I know I've got a negative inside the radical, so guaranteed I'm getting an I in my answer, right? And then I just have to simplify the square root of 5/12. So what's the square root of 5/12? I can break it up into the square root of 5 over the square root of 12. What's the bottom? 2 radical 3, good. Top's already simplified. Right, so you're gonna multiply top and bottom by radical 3. So what do we get on the bottom then?
2 times 3.
So I'm gonna get, what's that? 6, good. On top I get, and that can't be simplified, right? So, okay, last step.
Plus.
Good, and we'll just put that right in front of the plus or minus. So x equals positive 7/2 plus or minus the square root of 15 over 6. All right. So now we get two answers. They're complex numbers with imaginary parts, right? But they're in the form a plus or minus b times I. So we get them like we want them, right? Question?
Is there any way to check our answer?
There is. I mean, if you really want to check your answer on this, I mean, on the test, probably a good idea. Boy, it's pretty tough though. Pretty tough. What you have to do is plug them back in up here. I mean, that's a lot of work. It's a lot of work to put. Yeah, that's a lot of work. What I might suggest on one like that, instead of trying to plug it in, to check your work, I think instead I would just go back and, I mean, instead of like checking the answer, just check your work. Go back and just run through it and see if you can find any errors. Okay, sometimes you can. Questions on that? That's about the hardest one I could pick. I mean, that's a pretty tough one. So strategically, let's just spend a second and let's talk about, when would completing the square make a lot of sense? I mean, they can get kind of hard, but they could also be, they can be pretty easy problems. It can be a pretty quick and easy way to solve. But what makes it a little tougher? I mean, what about this one was tough? A lot of things were tough about this, but what was probably the first thing you saw that was a little bit tough here?
38. The fraction.
Okay, the fraction, good. So our b was odd, right? Now if our b had been even, dividing by 2 would have been fine, right? Then I would have ended up with an integer down here, and that would have made things quite a bit easier, right? So that's kind of a good rule of thumb. I mean, if you can see that you're going to get an odd b, then this is still, I mean, some people still prefer to do this. It's fine, but I might recommend then that maybe quadratic formula is going to end up being a better bet. But if b is even, this is pretty quick. It's pretty quick, and the quadratic formula actually has more. There's a little bit more simplifying to do with the quadratic formula. There's a little bit more arithmetic in the quadratic formula. It's predictable. It's the same every time. If you like it, it's fine. But that's kind of what I always do. If it's an even b with the square, if it's not going to be, I just move on to the next possibility. Okay. All right. So for today, this is only kind of for the honors class, but this is something I want you guys to get used to. This is a very good opportunity to prove a formula, right? What does that mean? Think what a formula is. Formulas are useful. The quadratic formula is handy because it works. It's completely general, right? It works for any quadratic equation in standard form. So when we want to prove a formula, how do we do that? Well, we want to be absolutely general, and we're just going to solve a general equation. So what's the most general place we could start with a quadratic equation? Standard form, right? Just the general form of our quadratic equation in standard form. And we haven't specified any of the coefficients. We're just going to leave them as A, B, and C. Or A, B, and C are just real numbers. That's our only requirement is that the coefficients are real numbers, okay? And so if we could manage to solve this equation that's completely general, then does it make sense to you that whatever our answer is, it's going to be written in terms of A's and B's and C's, and our answer is also completely general, right? It would apply regardless of what the values of A and B and C were, right? Does that make sense? So that's how we come up with the formula in math. We start general and we just solve the equation, and whatever solution we get, that's going to work in all cases then, right? So let's try this then. How are we going to do this? With, okay, indirectly, but we can't isolate x right now, can we? Right? So what's our only other option? We can't really factor it, right? Because we don't know what A and B and C are. So we don't know, we can't factor it. What's our only other option? If we can't isolate x and we can't factor it, what are we left with? Complete the square. Right? That's all we can do is complete the square. So what's our first step then? I want to subtract c, get that to the other side, and then what else do I have to do? Got to leave a blank, but we're still not, we've got to get this in the form x squared plus, okay, say it again. Divide by 8. You got to divide by 8 because we need x squared. Now this is going to be a little bit confusing because our b's are going to be different here. But if I go back to the last slide, our goal was to get it into this form. X squared plus b times x equals a number. Well, what do we mean by b there? B is just a number, right? Just some real number, okay? Is that exactly the same b that we have here? No, not really. It's going to be slightly different. But the b, what we want is just x squared plus some number times x equals a constant, right? So the way we can do that is we can divide by a, right? So let's do we got the two steps. Let's do those. If we get the c to the other side, we get ax squared plus bx equals negative c. Okay, we've got to have the coefficient of x squared be 1, so we'll divide both sides by a. And I'm just going to divide term by term. Okay. So the a's cancel. Now what do we get? X squared plus b over a times x equals negative c over a. So this isn't, in this case it's b over a, because the b's mean different things. But that's just a number, right? That's just some number times x. So we're fine. This is the form we needed in to complete the square. Questions? You guys see, give me a 1 to 5 on this. Do you see that this b is different than the b we talked about there? 5 if that makes perfect sense. 1 if, yeah, I don't know what they're talking about there. That's weird. Okay. Okay. Once again, this just represents, rather than call it b, I'll tell you what we could do. Let's call it, for now, let's call it capital B. So it's a different b. Right? So what we call the capital B here, which just stood for some complex number, in this case, when we're starting with the quadratic equation in standard form, the capital B ends up being little b over little a, in terms of those coefficients, right? Okay, so then now we're really to the completing the square step. So we're just going to, we got to be able to write this as a perfect square equals a number. Well, we already know what's going to be the number that goes here. And b over a, those are just numbers. It's going to be half of b over a, right? Well, instead of dividing a fraction by 2, we just multiply by 1/2, right? So we're going to get b over 2a. Everybody agree that's half of b over a? Okay. So then what's going to go, if that's true, then what do we have to add to both sides?
B squared over 4A.
Okay, and the way you're getting that, whatever that number is, we're just squaring it, right? So that's gonna be the quantity b over 2a squared. Well, if I distribute the two, if we just use properties of exponents, we're gonna get b squared over 2 squared times a squared. Right? Okay, so now we got these fractions we've gotta combine on this side. How am I gonna add those fractions up? What's my common denominator gonna be? 4a squared. Okay, so I've already got 4a squared in the green fraction. What do I have to multiply top and bottom of the blue fraction by to get that denominator? 4a. Okay. So if I multiply, if I do that, what's that going to give me over here? B squared minus c times 4a. Well, let's just rewrite that as 4ac. Right? Put the constant out front, the number out front, and then put the variables in alphabetical order. And we have a common denominator of 4a squared, right? Yeah. Okay. Okay, now what? Square root. So if I square root both sides, what do I have to include? We're discovering it right now. We could have done this. Oh, I mean, I don't know who first did this, but we could have, we might have, if this didn't exist, there's no reason we couldn't have just done this right now in class. This is not a big deal. You know, all we're doing is just solving, we're just solving a very general equation by using the same process we've used before. Nothing's different. The only thing that's different here is just that instead of specific numbers, we've got A's and B's and C's, but big deal. We treat them the same algebraically, right? So this really isn't much beyond anything that we've already done. What do I get on the right side if I square root this? I'm going to break it top and bottom, right? Top I can't simplify. So I'm stuck on the top with a radical. Square root of b squared minus 4ac. What about the bottom? Square root of 4a squared. That's, what's the square root of 4? 2. Square root of a squared. So that one does work, doesn't it? Right? I can take a square root of 4a squared. It's 2a. Now, conveniently, I've got the same common denominator there, right? So what's my last step? Okay, subtract b over 2a from both sides, and then I'm going to get the x by itself. Like always, we'll put that in front of the plus or minus. So I'm going to get negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But why not just write that with one common denominator, right? We've already got a common denominator. So our final answer might just look like x equals negative b plus or minus square root b squared minus 4ac divided by 2a. There's the quadratic formula. Right? So now we can use that as much as we want because we never specified what a and b and c were. So that's completely general. Right? Okay. So let's quickly look at a couple, just go through a couple examples, and then I'll let you guys work on this. There is one other little part I want to mention with this, though. The quadratic formula, there's a part of the quadratic formula that can be very useful in avoiding some work, in a good way. I'll tell you in a second. Let's go through a couple quick problems. So what do we do here? It's in standard form, right? It's got to be in standard form. So we just plug and chug. We're just going to plug it into the formula. So x equals, what was it? Negative b. So what's that? Plus or minus. So x equals
Negative b plus minus square root b squared.
minus.
Minus 4/8 divided by 2.
There you go. Right. Okay, so that's it. All you got to do is just plug and chug. Chug meaning simplify, right? So one thing though that I will say, when you're squaring a negative, what might be a better alternative? If you're squaring a negative, because if you put these into your calculators, which you inevitably are going to do, on this one you can't, because on this one they want an exact answer. But a lot of times you're just going to want a decimal answer, right? If you want a decimal answer, of course you're going to probably use a calculator. But when you square a negative, what's always the danger? Well, no. But like if I pull up a calculator,
Not gonna work. It's just gonna say no.
no blowing up. Okay, so if I try to square root a negative, or square a negative, sorry, if I do like -3 squared,
Error.
I get the wrong answer. How come?
Because it's not greater than multiplying by a negative.
Okay, because if I square a negative, I have to put the negative number in parentheses. Well, that's a lot of keystrokes, and it's easy to forget. So the moral of the story is, whenever I square a negative, what should I probably always just do instead?
Take the negative off.
Square the positive. Yeah, take the negative off. You don't need to add that negative at all, because you're likely to make a computational error if you do, right? And what do we get if we do this? We have to simplify this. We want exact answers this time, exact simplified answers. So we got to simplify radicals and do all that stuff this time. So 23 squared. Oh yikes! What's that going to be? 460 plus 69 plus 529. There you go. 529 minus 24 times 21 is going to be 240 plus 24, so that's 248. Is that right?
Let me get on my phone. 264.
264, is that right?
Sounds right.
No, that's not right.
248.
Yeah, 264 is right, that's right. 264, all divided by 12. Okay. So 529 minus 564, so that's what, 265? Okay. And we got to simplify that radical, so what do we got? 8. Oh, boy, I don't know if anything. 5 goes into that, 56, so we're going to get something out of it, so.
24 times 21.
Did I do that right?
4 times 6 times 21 is 5.
Did I mess something up? Oh, what should have been 504?
Yeah, but 4 times 6 is going to be a negative.
Oh, yeah.
Yeah, a negative
Multiply by 21. But if negative 4.
Oh, you're right, that's not right. Yeah, what should that be?
504 divided.
That sounds good. That sounds a lot better.
I was stupid. I was like, wait, what? How are you getting 264?
I don't know what I was doing. So 504. So 504, well, we got to do that one. What's that?
Make sure to,
Wait, you gotta subtract that.
549 minus.
Yeah, 529 minus 5.
Oh, yeah, there we go. That's where the 504 is supposed to be.
I'm not sure if it's 5.
Where'd you get 264? I don't know where.
Yeah, I know.
I'm not sure where that came from. So what's that giving us? 25? Oh, that makes it easy, huh? How about that?
Wow.
And what's the square root of 25? I'll get that wrong probably.
So,
So there's our two answers. We could simplify those both, right? So 28 over 12. What's 28 over 12? 7/3?
Yeah, about.
Or 18 over 12 be 3/2? So no big deal.
that's
Okay.
gonna do that.
Okay, what about something like this guy? Is that what I wanted? There we go. Got that one. What would I have to do this time first?
Add x squared minus.
Okay, I've got to get it in standard form first, right? Got to get it equal to 0. So if we added x squared, subtracted 7x,
3x squared minus 4.
okay, so I'm going to change the rules on you here, though. Let's say this time, instead of, I'm going to make this a little easier. Instead of asking for complex solutions, what if we were only asking for real solutions?
Well, the square root no.
Well, that's a problem.
Okay, so if we were doing this, what would be, let's try to be as strategic as we can. What part of the quadratic formula would we probably want to do first?
Square root.
The square root, yeah. If we go back and look at the quadratic formula, if we go back and look at the quadratic formula, would everybody agree that it's the part, whether or not this is going to have i's, or whether it's going to have, imaginary parts in the complex numbers, is all determined by the outcome of that expression, right? The only place we see a square root is just in, that one part of the quadratic formula. So if the number under the radical is negative, we know we're getting i's, right? So really all we'd have to do is just start by checking that. And do we even need to know what the value is?
No.
I mean, all we'd have to know, if we're only taking real answers, we wouldn't even, all we'd have to know is that, okay, that's going to be negative. And if I could see that was going to be negative, I'm done. The answer would be no real solutions, right? Everybody see that? Okay, so skipping ahead, let's just do that part. By the way, we give that part a name. I guess I left too soon. That part of the quadratic formula we call the discriminant. It's the discriminant, I guess, I don't know why, but it makes sense to me that it discriminates between the different types of solutions we could get. If the discriminant, capital D, a lot of times we'll call it capital D, is equal to b squared minus 4ac, what if the discriminant is greater than 0? What's going to happen?
It's gonna be good.
Well, what do you mean by good? Okay, so we're not going to get i's, right? And how many solutions are we going to get?
2.
We're guaranteed to get 2 because I've got negative b plus or minus some real number there. Everybody see that? Right? So we know we're going to get 2. If it's greater than 0, that tells us we're getting 2 real solutions, right? What about if, man, I'm not giving myself much room, am I? Let me slow down. Oh. Yeah. Okay, what did we say if our discriminant is less than 0?
No solution. Imaginary.
Okay, I'm getting no real solutions. What am I getting then?
Complex.
Getting i's. Good. I'm getting complex solutions with imaginary parts. And what about the in-between case? This is also interesting. What if d is exactly equal to 0? If d is exactly equal to 0, what is the square root of 0? 0. So then look at, look at my solutions. I'm gonna get negative b plus or minus 0 divided by 2a. Well, negative b plus or minus 0 means the same thing, right? So we get, in this case, we get one real solution, right? So a lot of times, that's where you'd want to start, isn't it? I mean, in this problem that we were doing, we'll deal with it later. How about that?